We're in Chapter 11 and we'll be looking at the subject of operational amplifiers and circuits, and they're commonly referred to as op-amps for short. We'll be looking at this particular section, 11.1, in three different sections, and so we're starting out with A, Introduction. An operational amplifier, op-amp, refers to an integrated circuit having well-defined operating characteristics, and we will be looking at those operating characteristics. A single IC may contain a single op-amp, or multiple op-amps may be contained on a single IC. So you may see an IC that is just one op-amp, or you may see an IC that actually has multiple op-amps on the same piece of silicon. Op-amps are widely used in computer circuits and industrial computer applications. Op-amps in electronic circuits may be assumed to be ideal for design and troubleshooting purposes, and this term that we're using here, ideal, we'll be looking at that more throughout this section. This addresses things like infinite input impedance and zero output impedance, and we'll, as we go along in this chapter, we'll find that for purposes of design and troubleshooting, the input impedance can be considered to be infinite. Now, it isn't infinite, but it is so large that for practical purposes we consider it to be infinite. And also the output impedance, though it is not technically zero, it is so close to zero that for design and troubleshooting purposes we can consider it zero. And there will be other properties of an op-amp that we will view as ideal as well. The symbol for an op-amp includes two input terminals, an output terminal, two power supply connections, and one or more compensation terminal, and we'll be looking at those terminals in a few minutes. The op-amp is essentially a differential amplifier with a single-ended output. Now, this is what your text says, and most of them are this way, by the way. Remember we talked about a differential amplifier, that it can have it has two inputs, and on the differential amplifier portion it can have two outputs. One was inverted, one was non-inverting. Most operational amplifiers will only use the non-inverted output. However, there are some op-amps out there that will actually use both, so it is not an inconcrete thing that they only have single-ended outputs. It's just that most are that way. Most op-amps use dual power supplies. When we say dual, we mean that there's a positive and a negative supply associated with them. Some op-amps have more than one compensation pin. These pins are used to fine-tune the behavior of the op-amp. With 0 volts on the input pin, some output voltage may result, and this is called the offset voltage, and can be either it could be either positive or it could be negative. Now, in some designs, the compensation pins are used to null out this offset voltage, and you need to recall that, well, actually don't need to recall, but with op-amps, the gain is typically 100,000. And so the tiniest voltage on the inputs can cause a rather large output, and so that's why sometimes they have these compensation pins to adjust for that output voltage that results. Okay, schematic representation. The 741 is a very common op-amp, and this is the multi-sim representation of the 741. We'll notice the inputs. There are inputs 2 and 3. This would be the inverting input. This is the non-inverting input, shown by the minus and the plus. Pin 4 is one of the power supply connections. It is for the negative power supply, and 7 is for the positive power supply. Pins 1 and 5 are used for offset if they are deemed necessary to be used. They're not commonly used, to be honest with you. And then pin 6 is the output. And let's see, down here we just have the basic symbol showing inputs and outputs, and in many circuits all you'll see is this. They don't give you all of the detail. And this is the schematic representations of the same thing from the previous page that we looked at regarding the symbol and the abbreviated symbol. So this is our introduction to op-amps. We looked at schematic representation. We looked briefly at offset voltage. And we looked at some of the characteristics of an op-amp.